Good day! Today, ang topic natin ay about problem solving involving exponential functions. So, how do we apply the concept of exponential functions sa problem solving? So, first, we have to take a review first about the population growth. So, last time, na-discuss natin to that suppose a quantity y doubles every t units of time. So, ibig sabihin, yung ating subject ay dumodoble every certain hours. If y sub 0 is the initial amount, so ibig sabihin may given tayo lagi na initial amount, then the quantity y after t units of time is given by this. Y is equal to y sub 0 times 2 raised to t over small letter t over capital T. So, bakit may yung y sub 0, walang problema, ito yung initial amount. Yung 2 ay because of the word doubles. Kapag yung word dito ay triples, edi 3 ito. Kapag ito naman ay halved, ito naman ay 1/2. Okay, so please take note of the word lagi dito sa ating problem. Raised to, yung small letter t dito is actually our input na time para magkaroon tayo ng output na y. Okay? Na kung ano man yung nagiging subject. And then, kung ano man ang subject or na tinutukoy doon sa problem. Over capital T, this is actually the time with respect to the rate. So, ito yung time kung kailan dumodoble, kailan triple, or kailan nag-half yung, let's say, bacteria or kung ano man yung usapan or subject sa problem. Let's take this problem here. Let t is equal to time in days. So, at t is equal to 0, so 0 days. So, first, wala pang araw yon. There are initially 20 bacteria. So, ibig sabihin, initially, meron kang 20 bacteria. Ito na yung y sub 0 mo, the initial population. Suppose that the bacteria doubles. So, meron kang word na double. So, take note mo yon. Every 100 hours. So, ibig sabihin, kada 100 hours, tumudoble yung bacteria. Okay, yung population ng bacteria. So, ang gagawin natin, give an exponential model for the bacteria as a function of t. So, ibig sabihin, ano yung input natin? Meron tayong function of t. So, ibig sabihin, ang input mo yung time, ang magiging output natin yung population ng bacteria. What is the population of the bacteria after 1,000 hours? So, ito naman, ilan naman daw yung population ng bacteria pagkatapos ng 1,000 hours. So, dito, iisipin mo na meron kang 20 bacteria, kada 100 hours tumudoble. So, ibig sabihin, sa 100 hours niya, yung 20 bacteria magiging 40. Pag 200 hours niya, yung bacteria mo from 40 magiging 80. So, hindi mo naman pwedeng i-manual compute kasi magko-consume ka ng mahabang oras. So, para makatipid sa oras, ay iwasan natin yung manual computation. Although, actually, pwede yung mag-manual compute, pero very tedious siya at saka time-consuming. Kaya naman gumagamit tayo ng mga general concept. So, again, ang input natin ay yung time. Okay? Kasi 1,000 hours. Ayan. So, ito yung magiging input at magiging output mo naman yung number of bacteria. Kaya magiging y. So, ang given natin, nasabi ko na kanina, yung 1,000 hours, ito yung small letter t. Ito yung magiging input mo. And then, yung output mo yung y, which is your number of bacteria. Yung y sub 0, ito yung initial, kung ilan yung initial population na given. Okay, so 20 bacteria. And then, yung 100 hours, ito naman yung time with respect sa rate na dumodoble. So, anong formula natin? Ito yon. So, y is equal to y sub 0 times 2 raised to t over t, capital T. So, again, yung 2 dito because of the word double. Okay? Doubles. Ngayon, to answer letter A, give an exponential model for the bacteria as a function of t. So, ang magiging itsura ng ating exponential model, ganito siya. Y is equal to 20 times 2. So, 20, yun yung initial bacteria, yung y sub 0, ito. And then, yung 2, ito yung doubles. Ayan. Raised to t. Yung t dito ay pwede mong ilagay na yung 1,000. Kasi ito yung input natin. Ito siya, 1,000 hours. Over 100, yung capital T natin ay, ito naman yung time with respect to the given rate na doubles. Okay? So, 100, dumodoble every 100 hours. So, over 100. Over 100. Ayan. Okay? So, ma'am, pwede bang exponential model natin y is equal to 20 times 2 raised to 1,000 over 100? Pwede rin naman. Pero para for uniformity sake, gamit ka muna ng small letter t over 100 to see na ito yung magiging input mo, t, at saka ito naman yung magiging output natin na y. So, to solve for y, we have to input now our input na time, which is ito, after 1,000 hours. So, magiging y is equal to 20 times 2 raised to 1,000 over 100. Using your calculator, pag in-input mo lahat to sa calculator natin, magiging answer natin ay y is equal to 20,480. So, the population of the bacteria after 1,000 hours is 20,480. So, example number 2 naman, what if exponential decay? Kanina kasi ay exponential growth. Ibig sabihin, dumodoble or nag-i-increase yung population. Dito naman, since the word decay, ibig sabihin nagdi-decrease yung population. So, suppose a quantity y is halved. Ibig sabihin, yung ating subject ay nangangalahati or nagdi-decrease yung kanyang population t units of time. Every t units of time. Okay? Kada specific time. Okay? If y sub 0 is the initial amount, then the quantity y after t units of time is given by this. So, again, ang ating input ay small letter t at ang output natin ay yung y. Okay? So, y is equal to y sub 0, the initial amount, times 1/2. 1/2 kasi halved. Okay? Raised to t, ito, the input over capital T, this is the time with respect to the rate na nag-half yung bacteria. Okay, let's have our example here. Suppose that the half-life of a certain radioactive substance is 10 days and there are 10 grams initially. Ayan. Determine the exponential model and determine the amount of substance remaining after 30 days. So, ano yung solution natin? Lagay muna natin yung mga given. Yung 30 days, ito siya. That is our input. Okay? The time input. Y sub 0 is our initial. Then, y sub 0 is ito. 10 grams initially. Ito yung ating initial population. Okay? Or, since gram siya, radioactive substance kasi, weight yung ating unit. Okay? And then, yung capital T is 10 days. Ito naman yung time with respect to the rate na nag-half yung radioactive substance. So, ang formula natin, nabigay na kanina, y is equal to y sub 0 times 1/2 raised to t over, small letter t over capital T. Okay? So, ang exponential model natin, substitute lang natin itong lahat ng given. So, dito sa ating formula, so y is equal to initial y sub 0, which is your 10 grams. So, 10 times 1/2 because of the word half-life, raised to t yung input natin, which is your 30 days. Mamaya inputan natin kapag solve na natin yung amount of substance. Over 10, okay, the 10 days, ito yung time with respect to the rate na nag-half nga yung radioactive substance. So, ang solution natin is, input na natin. Okay? So, the amount of substance remaining after 30 days, ayan, lagay na natin yung input para makakuha tayo ng output na y. So, magiging y is equal to 10 times 1/2 raised to 30 over 10. Using the calculator, ang lalabas na sagot dyan ay 1.25 gram. Ito yung magiging sagot sa ating amount of substance after 30 days.